Hello everybody, welcome back to the Intellectree channel. Today's video is all going to be about differentiation rules. Specifically, we're going to talk about the product rule. And this is going to be my first video in the calculus series, my calculus series, which this lesson is applicable to both AP Calculus courses AB and BC, so follow on for that. And again, this is part of Unit 2 differentiation rules in the AP Calculus AB/BC courses. So today in this lesson, in this video, you'll get to know all about the product rule, and you'll also be able to apply skills learned in this video to finding the derivative of a function that utilizes a product rule. So there'll be a worked out example, and then there'll be a lesson summary at the end. Firstly, before going into any differentiation rules or derivative rules, I want to remind everybody about derivative notation. Now, the derivative of any given function can be written in multiple ways, but these are the most common notation things wise where they can be written as. So, firstly, it can be written as d over dx. Now, d over dx is used when you're trying to represent the derivative of any function, but to use that, you have to have d over dx and then in parentheses the function and then put that equal to the derivative. So that's an appropriate way to represent the derivative of any given function. And then there's also another way, which is f prime x, f double prime x, and this way is really, really commonly used, even more than d over dx, because um, usually in calculus in the AP exam, you're asked to find usually more than the first derivative. You can be asked to find the first derivative, the second derivative, the third derivative, and so on. So to do that, to represent the first derivative, second derivative, third derivative, and so forth, we use this f prime notation where we have, the number of apostrophes, I guess you can say, represents the degree of the derivative of the function you're taking. So, for example, if you're given a function and you're asked to find the first derivative, you would use f prime x is equal to represent the derivative of that function once you solve for it. And if you're asked to find the second derivative, you simply have to change it a bit by saying f double prime, f triple prime, and the number of primes, I guess you can say, uh, basically represents the type or the degree of the derivative that you're taking the function to. And so these are just a couple of mathematically appropriate ways to write derivatives. And yeah. So what is the product rules? Well, okay, let's learn all about the product rule. So the product rule states that the derivative of any function that is a product of two functions can be found by utilizing the following formula, which states that to find this derivative of the function that is a product of two functions, you basically have to find the derivative of the first function times the second function plus the first function times the derivative of the second function. So again, we'll discuss this more in the next slide. So we have an example here where we can utilize our knowledge of the product rule and of derivatives. So we're asked to find the derivative f prime x, and we have to notice and identify what we're trying to find, right? We're trying to find the first derivative of the function given. We're not trying to find the second derivative. We're not trying to find the third derivative, just the first derivative itself. So our function given is f of x is equal to 4x sine x. And so here are a couple of steps that you can follow to find the derivative of any function that's a product of two functions as given in this example. Firstly, we would have to identify the two functions, right? We would have to find, what is the first function, or f of x, as they said in the formula, right? If we go back, what is f of x, or what is the first function that's getting multiplied, and what is g of x, or the second function that is getting multiplied. And based on that, we can plug things in easily and find the derivative, right? So second step would be to obviously identify which of those two functions is f of x and g of x. And an easy way to remember which ones are which is to just remember that, okay, f of x represents the first function, g of x represents the second function. And most of the times this works and is applicable to most mathematical situations. So then the last step would be, after identifying, what functions are what, is to just plug in those functions to the product rule and find the derivative f prime of x of the function, right? That would just be the last step in this process. So here is this kind of example worked out. So here in this example, we can identify, that within this function, f of x is equal to 4x sine x. We can identify 4x as the function f of x, or the first function, right? And sine x as g of x, or the second function. And within the product rule, which states, the derivative of the product of two functions, the derivative of a function that is the product of two functions is equal to the derivative of the first function, or derivative of f of x, times g of x, or the second function, plus the first function, or f of x, times the derivative of the second function, or derivative of g of x, right? So with finding the derivative, right, we have to use the rules that we must have memorized, or that we know, in order to find the derivative of each individual function here. So firstly, we have to find the derivative of f of x. And so f prime x would be 4, because f of x here, the first function we see that's getting multiplied to the second function sine x, is 4x. The derivative of 4x would be 4, because the derivative of, any function c of x would just be c itself, right? If we have a function that has, f of x is equal to, let's say, cx, where c is a coefficient, then the derivative of that function would just be the coefficient itself. So yeah, so the derivative of the first function, or the f prime x of 4x, would be 4. Now, with the second function, it's just a memorization thing, where we have to just memorize and truly understand that the derivative of the trigonometric function sine x is equal to cosine x. And so we represent that by saying g prime of x, right? G prime of x of sine x is equal to cosine x. And that's just an important thing to remember here. So yeah, let's move on. So next, what we have to do is we have to plug in what we know, right, into the rule that the product rule states. So again, right, that is what the product rule states. And after finding the derivatives of both functions and doing all that, we can easily plug in everything we have into the formula. So when we do that, we get 4 times sine x plus 4x times cosine x. When we simplify, we get, we have to do f prime of x of 4x sine x is equal to 4 sine x plus 4 cosine x. And so this could be our final answer, but instead of that, we could go another step, and that would be to factor out the 4, because that is something we can do, and that is something we can do to simplify our answer. And so within the AP Calculus courses, especially with differentiation problems, the most important thing we can do is to simplify our answers the most where we can get them. So it's always better to simplify than not. So to make our answer simplified, we can factor out the 4 from this equation to get f prime x, right, the first derivative of this function, 4x sine x, is equal to 4 in parentheses sine x plus cosine x. And yeah, so we just get f prime x of 4x sine x is equal to 4 in parentheses sine x plus cosine x as our final answer. And so it's really important to remember how much we can simplify, and we have to identify how much we can simplify our answer to a given problem that we've worked through, right? Because that eventually can either get us the point or not get us the point. So that's important to acknowledge here. So here is the lesson summary for today's video, the product rule. So firstly, I just want to remind everybody again, the product rule states that the derivative of a function that is the product of two functions is the derivative of the first function, so that would be f prime x times the second function, or g of x, plus the first function itself, so f of x, times the derivative of the second function, or g prime x. Now, this rule is used heavily and most commonly when finding the derivative of a function that is a product of two functions. So if you have any function, if you see any function, if you identify, okay, there are two functions getting multiplied by together, and to get the function itself, then you have to use the product rule no matter what to find the derivative, because this is the most efficient, effective, and useful derivative rule to find the derivative of that function. And lastly, always identify all the components to a problem, right? Rewrite the problem if needed, and in the end, simplify as best as possible to obtain the answer in the end, right? So these three steps are important within differentiation. If the function is in a hard state to differentiate, identify all the components of the function given, rewrite it, right? For it to better make sense, for it to look better, for it to be differentiable, right? Easily. And then simplify in the end, right? Simplify your answer, simplify what you got as your derivative, so that you can better identify, rewrite, and simplify with every other problem you do, especially in relation to differentiation problems. So that is going to be the end of this lesson for today about the product rule within the differentiation unit, Unit 2 of the AP Calculus AB and BC courses. Follow, like, share, and subscribe to the Intellectry channel to get more updates on new videos that might come out and just more knowledge to share. Thank you. This is Intellectry signing off.